Thank you, Jana. Thank you. And are you enjoying today's drive session? Okay, I hope so. And again, good afternoon, everyone. And thank you for joining us here today. I'm Satoshi Ogiso, and I was assistant chief engineer for first generation Prius, and I did chief engineer role for second generation Prius. And current generation, I'm so-called executive chief engineer or so-called group chief engineer for entire Prius family. And as Uchiyamada said in his welcoming remarks last night, this is the first time Toyota has gathered its current full global fleet of hybrid vehicles. So it is also the first time that I have seen them assembled together as well, actually. You can imagine how I feel at such a family reunion, very special. As I'm sure everyone understands, this event is focused on our entire lineup of hybrids. It is my job to give you a taste of what we have in store in our hybrid future. However, it's impossible not to begin with how it all began. I was one of the lucky engineers to be assigned to the G21 program in October 1993. This is me more than 20 years before, and everyone easily recognized that he looks very younger, and the only guy without tie. This is one of evidence that I love freedom, and at the same sometimes I break rules itself. And I had been working for Toyota for 10 years, and I was assigned to the product planning department. G21 stood for Global 21st Century. Ironically, its goal was not to develop a hybrid vehicle. Instead, its goal was to develop an affordable 5-passenger family car that would address the fuel efficiency and environmental needs of the 21st century. Our focus was not on the next generation. It was to be much farther into the future. Initially, the idea was to develop a car that delivered 50% improvement in fuel economy of a typical Toyota compact sedan powered by a 1.5-liter engine before the beginning of 21st century. At the time, a separate powertrain group was showing considerable progress on a gas-electric hybrid system that eventually became the key to achieving our cost and performance targets. As the benefits of going hybrid became cleaner, there was an important change in our strategy. Instead of doing what we could, we would try to do what we should. A new goal was set. Again, based on a typical compact sedan and 1.5-liter engine, we would double fuel efficiency, cut emissions in half, and reduce development time by 2 years. To achieve these goals, many diverse elements would come into play, including things like aerodynamics, rolling resistance, and lightweight. Does anyone know what these numbers represent? 80, 20, 4, 1. At the time, we identified 80 different hybrid configurations that could be considered. We narrowed it down to the top 20, then ran them through simulations seeking overwhelming fuel efficiency and found 4 prime candidates. At this point, we could assess degree of difficulty and cost. The clear winner was a series parallel hybrid design with fairly simple hardware of 2 motors and planetary gear set, but highly complicated software. Despite the complexity and upfront investment in the software, increased volume would not mean increased cost. This would be the most viable system with an eye to the future. During G21 development of single car, the Prius, it became clear that series parallel technology was adaptable to a broad range of vehicles. In fact, there was no reason to think that every one of our passenger car could one day offer a hybrid powertrain. Most importantly, it seems to be a system that held great potential for constant improvement for many years to come. Uchiyamada-san would be right if hybrid was a bridge technology, but it looked like a very long bridge. About the time we launched Prius in the US, we set in motion just such a long-range hybrid development plan. Here in the US, we began with the simultaneous development of hybrid version of the Toyota Highlander and Lexus RX. In Japan, we added the Estima and Alphard minivan. Prius, which means go before, would be the first of many diverse takes on the basic hybrid concept. Since the launch of Prius in 1997, we now have 23 Lexus and Toyota hybrid models in various global markets, including Prius plug-in. When the next generation Prius arrives, it will begin a new era for the broad range of Toyota and Lexus vehicles by making the arrival of a substantially improved family of hybrid powertrains. Think of it as Z21.5. These new hybrid powertrains will deliver significantly improved fuel economy in a more compact package that is lighter in weight and lower in cost. The performance of this new generation of powertrains will reflect significant advances in battery, electric motor, and gas engine technologies. And it's part of Toyota's larger portfolio strategy toward the electrification of the automobile, including plug-in hybrid, battery electric vehicle, and fuel cell technologies. Toyota has a deep commitment to vehicle electrification and therefore in advancing drive battery technologies. Our next generation of hybrids will feature improved batteries with higher energy density. That is the relationship between the battery's output and dimensions. We have stepped up our research, development, and production capacity on both nickel metal hydride and lithium ion. And looking to the future, we have ramped up development on new battery technologies like solid state and lithium air, as well as devoting resources to new chemistries beyond lithium, such as magnesium and other low valence materials. The next generation Prius specifically will combine our advanced battery technologies with new electric motor that's smaller in size and feature improved power density. For example, the current Prius motor provides 4 times the power density of the first generation. The next Prius power density will be even higher. Sometimes, lost in the discussion of hybrid is the importance of the gasoline engine and its thermal efficiency. For example, the current generation Prius gasoline engine has a thermal efficiency of 38.5%, The new engine in the next Prius will be more than 40% our world's best. So where do these advancements take us? The current Prius has been America's fuel economy king for many years. In its 3 generations, Prius MPG has improved on average by about 10% each generation. The challenge to continue to improve at this rate, to beat your own record, becomes very difficult, but makes it all the more motivating. I can tell you that we are very motivated to beat our record. To complement these substantial gains in powertrain development, the next Prius will ride on a vastly improved chassis. My background is chassis engineering. In fact, I chose to come work for Toyota when I was much younger than previous photo, because of the Corolla GT 86. The 86 is the origin of the FRS, Simon FRS. The next Prius will feature the Toyota New Global Architecture, or TNGA. It will have a lower center of gravity and increased structural rigidity. This, along with many other improvements, will allow for beneficial gains in ride and handling, agility, and aerodynamics. Its interior will be roomier with significant refinement in design, layout, and ease of operation. And it will introduce key advanced safety technologies. Developed in parallel with the next Prius will be the next generation Prius plug-in. We have been listening very carefully to Prius PHP owners by past 2 years and are considering their request for additional all-electric range. We also have heard from these owners that they would like a more convenient charging operation. In response, we are developing a new wireless inductive charging system that produces resonance between an on-floor coil and onboard coil to recharge the battery without the fuss of a cable. We will begin verification of the system in Japan, the US, and Europe in 2014. About as long as we have been selling Prius, we have been developing another form of hybrid technologies of critical importance to future mobility, delivering zero emissions along with driving range and refueling time on par with conventional vehicles. Hydrogen will be in our future for a long time. Toyota's first commercially available hydrogen fuel cell vehicle will go on sale in global markets in 2015. At the 2011 Tokyo Motor Show, we unveiled the FCVR fuel cell concept. This year, at the Tokyo Motor Show, we will get a bit more specific when we unveil a well-defined mid-size four-door sedan concept. That vehicle will make its North American debut at 2014 Consumer Electronics Show in Las Vegas in January, where Bob Carter will discuss the role of our US-based engineering team in its development, as well as a few of our preliminary plans for the introduction into the US market. For now, I can tell you that the hydrogen fuel cell stack is currently developing 3 kilowatt per liter of power density. We believe that the world's best and about twice that of the fuel stack we have been using for the Highlander fuel cell vehicle that many of you have already driven. If you have not, please take the opportunity during our ride and drive segment. Finally, I would like to address how hybrid technology is influencing motorsports and how motorsports will help us develop better hybrid technology in the future. In 2007, with the passenger car HSD serving as a starting point, we began work on high-performance technologies and components needed to develop a hybrid drivetrain for elite competition, specifically the TS030 World Endurance Championship Le Mans prototype. The challenge of the hybrid race car was being the added weight of the battery and electric motor. The TS030 uses supercapacitor instead of batteries, which shows great promise for their ability to recover, store, and release energy very quickly. This potent hybrid powertrain integrates a unique inverter with a 300 horsepower electric motor generator sandwiched between the 6-speed transmission and the 530 horsepower V8 engine. The extreme nature of racing tests the durability and reliability limits of vehicle components, system, and software, helping make TS030 the world's fastest and possibly the most effective rolling hybrid laboratory program. Bob Carter mentioned earlier today that to take full effect, hybrid technology must be consumed in high volume. Regulatory push cannot on its own induce consumer pull. To truly have an effect, our industry must develop a diverse array of products that consumers are willing to buy. Where the cost premium is lower, convenience is high, and the benefits to the environment and the pocketbook are clear, which is precisely where we believed hybrid would be 15 years ago. Today, patience and long vision are still the cost of admission because consumer adoption of less convenient and higher cost technologies have been slow and will continue so. But 15 years from now, I believe that plug-in hybrid, battery electric, and especially hydrogen fuel cell could be as common as hybrid are today. Perhaps members on my staff working on fuel cells will be able to say they were in on it from the beginning the way I have been with hybrid. I believe that will happen. Yeah, I truly believe that will happen. And now I will turn to meeting back to Jonathan.